right. Oh, good morning, good afternoon, good evening, everyone. We're just going to have a couple minutes to let everyone come in. I'll mention straight off the bat, we'd really like this to be a interactive discussion. So we're not going to monitor who's muted, who's not muted. If you're in a place with background noise, please mute yourselves. But we'd be very happy to have an open discussion. So you'll be more than welcome to unmute yourselves, have a conversation, and go back on mute. Thank you. And we definitely appreciate all cameras because we'd love to see who we're talking to. All right, so we have a few people coming in. There's just somebody with a little bit of background noise. If I could ask them to go on mute. Otherwise, I think so far we're pretty good. All right, I see you have started the recording, Lisette. Thank you very much. And I think we can potentially kick off the meeting for today. And this is being recorded, so as people come in, they'll be able to pick up the beginning of it if they missed it. So hello, everyone. Once again, my name is Erica Bassin. I am from the Advisian team. We'll have a few introductions come in soon, and I'm really glad to see all of you out there. We've published a paper in correlation with VoltaChem, TNO, Worley. We've all come together to put some thoughts together on green hydrogen, especially in Europe. And we're really happy to be having this webinar today where we share some thoughts. We have our experts on the panel, and really we're looking to have a discussion with yourselves and come out with some fruitful points, notes to take with us and see if we can proceed our journey in green hydrogen together. So without further ado, I will first hand over to, well, actually, sorry, I'll go through the agenda really quick. A quick round of introductions, but really getting into the meat of the discussion soon so that we can have a good amount of time for an open discussion before the end of the hour. So we have Ian Moore, Piotr, Lennart, Christiani, our panel of experts here to talk about end use, market development, technology, and legislation. And actually, we've had a last minute substitution. I think Piotr's having some technical difficulties. So Eric from VoltaChem has very kindly volunteered to help us out with the supply chain piece. So thank you so much, Eric. So some really quick house rules. Please, like I mentioned, please put yourself on mute if there's a background noise around you, but we would like this to be an open discussion, so you'll be very free to unmute yourselves and have a discussion with us. Please raise your hands. If we start seeing people talking over each other, we'd really appreciate you raising your hands. Please feel free to ask any questions in the chat while the presenters are presenting, and then afterwards we'll keep it open for all. And please be informed that this webinar is being recorded and will be available to everyone at the end of the hour. Okay, so then can I please welcome Lennart onto the forum right now to please introduce VoltaChem.
Thank you very much, Erica, for this introduction. Welcome to you all. For the one who are not familiar with VoltaChem, 5 years ago, we started an initiative called VoltaChem to accelerate industrial electrification, basically. And I mean, it sounds easy, but as you all know, we need to have obviously the chemical industry, which highly relies on fossil energy, which need to decarbonize in at least 1 decade to get serious started with that. We need renewable electricity, solar, wind, renewable energy companies, and we need new equipment. And basically, these are 3 different sectors. And what we do with VoltaChem the last 5 years, we actually combine these companies from these sectors and innovate new technologies. Focus on water electrolysis and also focus on CO2 electrolysis. So basically the next steps. Can we make new chemicals with direct electrification? And it's not only technology development, it's also developing markets, developing policy, and that we're doing together with industry. So I invite everyone who is not familiar with VoltaChem, please visit this website and become part of this community. It's really have an international focus, and not the Netherlands only, but really international focus. And yeah, we want to have all leading partners involved who are dedicated to make the chemical industry completely renewable based, at least within 1 decade, I would say. So that was my pitch and introduction to VoltaChem, Erika.
Thank you, Leonard. I should have mentioned Leonard is the business development power partner at VoltaChem for Power to Hydrogen. So thank you very much.
Yeah, thank you.
Moving on, then I'll take just a couple minutes really quickly to introduce Advisian, which is the organization that myself, Ian, and Christiane are representing. Advisian is really the consulting arm of our multinational engineering parent, Worley. You may or may not have heard of Worley, but we're an Australian company, but really operating in over 20 countries in the world with projects in traditional energy, traditional chemicals and resources, but also now focusing more on the energy transition and really looking at the upcoming technologies in the energy transition space. So Advisian, we are the consulting arm that will work mainly up to pre-feed, and then after that, the projects are handed over to our EPCM parent company, Worley. Anything to do with configurational studies, market studies, lenders technicals. There are different parts of the business, and in those different lines of business, the low carbon team where we sit in really has work in every single sector and in every single type of job, because the focus now is really to accelerate this energy transition and have all our different industrial sectors move towards net zero wherever possible. So just a quick introduction to us. Our website is there, and we'll be more than happy to connect with you after this webinar, whether it be regarding the paper, whether it be about your own decarbonization strategies and how we can help develop that. So thank you very much. And without further ado, we'll jump into the meat of the discussion for today. Firstly, I'd like to introduce Mr. Ian Moore. He's the technical director at our low carbon team here in Advisian. So Ian, over to you.
Thank you, Erica, and welcome to everyone. On the face of it, it may well look like we're spoilt for choice where we can use low carbon hydrogen. On this slide here, on the left-hand side, we have a series of sectors, and within each of those sectors, we have potential hydrogen applications. And this may be sort of heat and power supply, power generation, or grid stabilization. It may be hydrogen injection into the grid, seasonal storage. Under transportation, we got planes, trains, and automobiles, and we can potentially use hydrogen directly or convert it into an e-fuel for more of a drop-in fuel. We have a wide range of industry, in particularly energy-intensive sectors, and I guess the sectors which use hydrogen as a feedstock, plus where there are large heating duties. And then in chemicals, I guess the largest probably methanol, but then also we can look to use byproducts of the green hydrogen production, such as oxygen. But I think we have to be pragmatic, and we have to be wary of considering hydrogen to be a silver bullet for all applications. And I find it helps to focus on sort of two thought processes. One, what is the counterfactual fossil fuel which we may replace with hydrogen? Is that going to be coal or natural gas? And natural gas price can vary from North America to Europe to maybe in some countries it's subsidized. Around transportation, it's often diesel and gasoline. And I guess we tend to start by thinking, where can we replace the highest value or highest cost fossil fuel to improve the economics? So I think considering a counterfactual is very important, and then also considering what the other low carbon competitor is for those applications. So for example, in passenger cars, obviously EV, and we have to question, does it make more sense to power, use electricity directly to drive a car, and to convert it to hydrogen, to convert it through an engine back into power again. So again, it's being pragmatic. Around biofuels, and we talk about sustainable aviation fuel and e-fuels, and again, where do we most use the limited biomass resources versus to what added value we get by using hydrogen. And these issues will vary from geography to geography. So it's very important that we target sectors appropriately. And next slide. So if we sort of take this approach, we basically lead to developing a sort of heat map of where at this moment in time we see the greatest potential for uptake of hydrogen. And I think from our experiences, the obvious first place is where we were using hydrogen as a feedstock already, be it refining, ammonia production, methanol production, and say in the Middle East, in a direct reduction steel process, where we have a high technical readiness level of using hydrogen because we're already using grey. So we have high rapid potential uptake, potentially incentives. My colleague Christiane will touch on that later. There are very few alternatives when we use hydrogen as a feedstock, so that's good. And in some of these industries, the volumes are very high. So I think we can look across the spectrum through into steel industry, hard to abate sectors such as cement, and then into transport, and finally into sort of industrial and commercial heating. But I think, just to summarize, we need to focus on where we can drive the best business case, where we have the most incentives, and where we can kind of get growth in volumes as quickly as possible. So that's just a scene setting.
That's fantastic. Thank you, Ian. And we'll definitely have some questions for you at the end of the panel. We'll now move on to Mr. Eric. And I know, Piotr, I see you on call. If your audio is...
Yes.
Oh,
it's
lovely.
working.
Okay, fantastic. So between Eric and Piotr, we'd love for you. We'd love for you to talk about the supply chain. So Piotr is a energy and materials transition specialist here at VoltaChem, and Eric is a senior strategy advisor. So over to you.
Yeah, thank you very much, Erika. I will provide you a snapshot of what are the main challenges concerning the building a mature supply chain, maturing the supply chain, specifically in the case of clean hydrogen. Of course, this is only this is not extensive list. I think more discussion you can find in the report itself. I assume that majority of our listeners today, participants, have read the report. If not, this is only the most important, maybe the most important elements that I'm talking about now. So, in the first place, what's hampering development of the mature supply chain is the tightening EU targets. They are growing, you could say, every year. Even recently, we've got a lot of new updates. And those targets, tightening targets, are also connected to geopolitics. And there is a lot of discussion these days on how, for example, the Russian-Ukraine conflict may impact the growth of clean hydrogen and building the supply chain. It will cost, of course, a lot of time and a lot of energy and resources and capital. And those disruptive changes, like sudden wars on the European continent, impact those forecasts very significantly. The second is, of course, the accelerated decarbonization, which is, in the first place, the introduction of the carbon tax. We see that the major industry sectors, given the situation and scarce capacity concerning the growth of clean hydrogen, may get into competing situation or competitive situation when it comes to arranging this access, and arranging the access also to cheap renewable energy, being an important feedstock for production of clean hydrogen. So we need to be very careful about those developments. There is a lot of tension coming in this area. The next one is indeed renewable energy capacity growth. The scenario we've been concentrating on was 2030 ambition of European Union to build around 40 gigawatt of water electrolysis capacity around this time. In the meantime, of course, these targets have been sharpened, and there will be 40 plus. I'm not sure how much, maybe we can have it. We have a small discussion on this one in the next phase of the webinar. But there is really 40 plus gigawatt of water electrolysis being added at 2030, and there will be not sufficient renewable energy to feed those electrolyzers. Then the next one is, of course, system integration and complexity and related costs. The figure in this in my dia shows how this evolution will find place in the Netherlands. We have the power grid, legacy power grid, and we have also legacy natural gas networks. And those, in principle, looking at the topology of those could be overlaid, connected or integrated together, and make way to construct, as we call it, integrated grid, providing also access, transport, and access for green hydrogen. This is, of course, a nice picture of a small country like the Netherlands, and this is easy to draw, but of course the situation becomes much more complex if we talk about system integration on the level of large European countries like Germany, France, Poland, and others. We know that design, building, and manufacturing, and maintenance and operation of clean hydrogen infrastructure might be an issue, especially when you get into this integrating exercises, and also building the storage facilities supporting this integrated system will be also very expensive and might as well add a lot of complexity, not only technically speaking, but also concerning the financing, which I will leave for the next phase of this webinar in the Q&A part, because bankability is a nice term which contains a lot of, and summarizes maybe and couples links a lot of aspects dealing with supply chain, and a nice subject to talk about.
Lovely.
That's all from me. And over to Lennart.
Thank you, Piotr. Yes, that's right. So Lennart, over to you. We've done your introduction, so please take us through the technology piece.
Thank you very much. I think one of the major challenges, I mean, we can set a lot of targets where we want to go with green hydrogen production. The biggest challenge is how we can shorten the innovation cycle. If you really look at the numbers between 2008 and 2018, let's say, within Europe, 170 megawatts of electrolyzers being deployed cumulative. So within 10 years, 170 megawatts. So that's nearly one project where we're discussing now. So we see the size of the projects are increasing, but we need to learn much faster. And the picture you see here is like a typical innovation cycle. So we need to have first pilot projects, then we go to multiple demos. We learn from these demos. We're going to do even to larger scale, and then we go to rollout. And the challenge is how we can learn faster. And obviously, you've got market incentives. I think at the moment, the whole hydrogen development is steered by the government. The government setting clear policies. Later in this webinar, we go more in detail with that, because the Fit for 55 had a really clear target for green hydrogen. So that's really steering the directions. But here we give 3 clear examples how we think we can accelerate the innovation. And the first is increased data sharing. If you look at the Netherlands is investing 7 billion euros the coming years on hydrogen projects. And what we see at the moment, there is limit incentive of companies for sharing data of these electrolyzer projects. But there's really a good argument for increasing the data sharing in order to support faster learning, enable new entrants. And also with topics like safety, there's still a lot of discussion how we go to an inherent safe electrolyzer, maybe too ambitious, but at least learn from best practices in electrolyzer project. And now we see different electrolyzer suppliers and also hydrogen developers going to the same learning curves over and over and over and again. And we should think of a way, and especially in the government-funded projects by IPSAI, for example, how we can share the data and the learnings in these projects much more efficiently. So that's our first recommendation, increase data sharing from the first hydrogen projects. And always we have a discussion who will be the owner of the data. Obviously the one who has operating the electrolyzer, the one who supplied the electrolyzer, but it's important to get as much as possible the learnings, and that not all the companies need to go for the same learning curve. So that's the first one. The second one is we need to work on parallel technology. Obviously PEM and alkaline, this is the most mature electrolyzer technology at this moment. New technology will come into play is IM and solid oxide electrolyzer. This solid oxide electrolyzer, the largest one, will be developed in Rotterdam at Neste, where Sunfire is working on a 2 megawatt plus electrolyzer, but still it's in the beginning. And you see the supply chain of these electrolyzer technologies is also still immature. A limited number of companies are active in developing components and stacks for these technology. So it's not only about electrolyzer itself, it's about the manufacturing, it's about the supply chain, and to have real-time data of the performance of these electrolyzer technologies. So we need to work in parallel on next generation technologies. And the third one is set really ambitious targets. In order to stimulate innovation, you can argue from, especially for Europe, it's important to set clear targets. And I mean with clear targets, I mean targets on, for example, efficiency of the less use of scarce materials. We all know that electrolyzers use as a catalyst precious group metals, critical raw materials. And if we're not now setting clear targets, we are running to a wall at a certain moment because there is a shortage of for example, iridium available. There's 7 ton iridium available as a catalyst material, and all this iridium, not all, like 80% is coming from South Africa. It's not a problem at this moment, and the market won't solve it at this moment. So we should stimulate companies to come with solution, because we need the solution within, we need to work now on solution to have it available between the next 5-6 years. So that's really important that governments stimulate in these innovation projects, subsidized projects, to stimulate these issues which will come into play in the next 5 years. And if you go to the next sheet, Erika, I give you an example of the innovation cycle we see for PEM electrolysis. So you see the first generation PEM electrolyzer. You see all electrolyzer suppliers are focusing on cost reduction, standardization. So they want to go from project to project, standardize their electrolyzer design, and go from a manual manufacturing to semi-automatic manufacturing, at least of the stack. The balance of plant is a different story, but at least of the stack. If you go to the second generation, we see basically the same stack design in terms of geometry, but with new components, optimized components. So you can think of thinner membranes, lower catalyst material. So improved components, but with the same electrolyzer design for the PEM. And then we go to a third generation. We really see a radical change of the design of the electrolyzers. You're not having a CCM anymore, catalyst coated membrane. You maybe go to PTE, porous transport electrode, so which improves the circularity of your electrolyzer. And go to new materials. For example, in the PEM, we're running to the issue of this fluor membrane, which is now on the list of the PFAS materials. So we need to look also for new properties, new materials for these electrolyzers. So really, third generation, new design of the PEM electrolyzer stacks. And this for PEM. We made the same roadmap as well for solid oxide electrolyzer, and also for new technology like anion exchange membrane. But this generation thinking is more and more coming standard in the electrolyzer development. So we need to focus on getting the products on the market, but in between looking for developing the whole supply chain. Because at this moment there's only 1 or 2 really suppliers of membranes. So we need to have multiple suppliers on the key components in order to have a sustainable supply chain, basically. That's what I want to say, Erika. I think.
Amazing.
Yeah.
Thank you, Leonard. And we'll have time at the end to touch on those thoughts. So I'd like to now introduce Christiane. She's a colleague from the Advisian low carbon team and our legislation and policy expert. So over to you, Christiane.
Thank you, Erika, and hi everyone. As Lenny was saying, electrolyzers is likely to become a mature technology in the next decades, and we needed to organize the supply chain, and policy with favorable legislation subsides will be crucial to speed up the uptake of these new technologies and bring it together all the elements to create a hydrogen economy. And the EU hydrogen strategy kicks off this hydrogen journey with a non-legally binding target of a 40 gigawatt total capacity of green hydrogen production across Europe, and seizing them since 2020 to support this EU commitment, these EU ambitions. Several proposals and revisions are going through a negotiation and implementation process. For example, in 2021, we had the Fit for 55, which comprises a range of policy updated documents mentioning green hydrogen in most of them. As for example, the RED II, the ETS, the CBAM, and along with the Fit for 55 package, there is also the Repower EU, published last year, calling for 10 million tons of domestic green hydrogen by 2030, plus another 10 million tons of imports in order to reduce the consumption and imports of natural gas and fossil fuels. In next slide, there is a continuation to this journey. Yes, showing that between now and 2030, it's likely that many new policies will be implemented, and also alongside the creation of some regulatory organization, such as the Network for Hydrogen Operators, the CBAM Authority, the Hydrogen Bank, and so on. But in this slide, I want to show some of the key legislation. For example, CBAM and ETS, there are two policies that indirectly favors green hydrogen, green fuels, and green products. In short, by imposing a carbon tax on fossil fuels and fossil-based products. Under the ETS sectors, green hydrogen starts to receive free allowances from 2026, although we have these free allowances phased out by 2034. And with the implementation of CBAM, the EU importers have to buy certificates corresponding to the EU carbon price. So EU importers of like gray hydrogen, gray products needed to buy the certificates. Especially on green hydrogen. So the Hydrogen Bank, which is still a draft, proposes a support mechanism to incentivize hydrogen production in EU countries. It might place a premium price to green hydrogen, but details and how it's going to work, we expect to be published by next year, by 2024. And I'd like to mention that a key legislation is the RED II, the Renewable Energy Directive, and its proposed revision named RED III. So under the revision of RED II, we have the delegated acts. The first one is a key one where it set rules to use renewable electricity and also defines the conditions for green hydrogen to be considered fully renewable and also eligible to count towards the EU targets. So, and also this revision of RED II proposes ambitious targets to hydrogen to be used in industry and also across transportation sectors. So in my last slide, I show, yes, so I show these proposed binding targets under the RED III. For industry, 42% of hydrogen used in industry should be green, with an estimated demand of 4.2 million tons of hydrogen in 2030, as well as targets for road transport, aviation, and marine. So if these policies come into force, become a EU mandate, it will be a strong driving force to hydrogen uptake. And just to conclude, in the table in the right side, I show a list of these different policies running through the main pillars of the hydrogen supply chain, since certification, price, until production. And also it's important to mention that many of these proposed regulation policies are in an early stage of development and needed to be passed between Parliament, Council and European Commission, needed to be adopted. But once they come in place, they will be key to create a market demand, infrastructure and supply chain for hydrogen. We're going to talk about a little bit more in the QA section, as Pietro was saying, in the bankability for hydrogen. But in the following slide, Erica shows how we can accelerate this.
That's right. Thank you so much, Christiane. And Thank you to all our panelists who've shared their thoughts so far. So if you haven't yet looked at the paper that we're referring to, Green Hydrogen Today, Tomorrow, and 2030, it was really a thought leadership piece where the two organizations came together to see really what elements of our hydrogen economy need to align in order for the hydrogen economy to become a reality. And this really includes, where there is a demand for the product, where there is a ready supply for the product, where there is an uptake appetite, and where there's a legislative environment that is supporting technology development and providing subsidies to really get introduced to and acquainted to this. I wouldn't say a new product. Hydrogen is, it's been around in industry for years, since the beginning of time almost, but a new green hydrogen economy that we're seeing developing. So the paper, we've tried our best putting our thoughts together to see what cycles need to be accelerated and what different components of this economy need to align in order for a hydrogen economy to become a reality. And now I think I'll open our discussion up to the audience, to our listeners. Thank you so much for joining. If you've read the paper, if you have any questions outside of the session today, anything to do with the paper itself, we are more than happy to take any questions. Lisette, I think you'll help me monitor the questions coming in the chat.
Yes, that's correct. Yeah.
Lovely. I do see a question by Javad. I'm sorry if I've mispronounced that name. But Javad, would you like to, I see the question is, are these rules just for the EU? I assume this is for the legislation piece that Christiane was just talking about. Is that right, Javad?
Yeah.
Yes.
Lovely.
Hi.
So,
Hi.
Yes.
Yes, no, actually, yeah. So the DAs set these rules, and it applies to any country wanted to export green hydrogen to EU. So
Okay.
US, yeah. So
Yeah, I'm from California, so I just wondering what is gonna be the the future for California in terms of the rules and regulations.
yeah.
I think I can just say, obviously in the US, we have the Inflation Reduction Act and all the incentives that fall within that. And I guess every geography is going to have its own, decide its own economic drivers, whether it be Europe, North America, North Africa, Middle East, Asia. And it's going to be developed very quickly. And I think a link between export and import means that even if you're sitting in North Africa or California and you want to export into the EU, then you need to understand the rules. And I guess EU companies and technology developers also need to understand what's happening in, say, with the Inflation Reduction Act, and there will be competition between these jurisdictions, and I think they will learn from each other, and some of the principles developed in one jurisdiction will be transferred across to other, and some won't. So I think it'll be a very complicated but moving space going forwards.
Thank you. Thank you.
thank you, Ian and Christiane. We see a couple more questions in the chat. So one from Jacques. What steps can electrolyzer OEMs take when scaling up manufacturing to prevent lock-in of first generation technologies? I think that's a very good question. And I think, Leonard, you can hopefully start us off with an answer.
Yeah, that's a good question. I mean, if you look for the case for PEM, if you look to the difference between first and second generation, it's actually a drop-in. So we define the second generation as the existing design, but with improved components. So you can then define to work together with your suppliers for your membrane, your key components, with new components. So you can go to thinner membranes, improve catalyst, also improve balance of plant components. So that if you keep on the same design, it's easy. If you go to third generation, yeah, then you go to a complete different stack design on the stack itself, and also maybe the geometry, and that will be difficult. But I think, and if you go one step further, for example, you now develop a gigawatt alkaline system, and you want to move towards PEM or IM, yeah, I think that's an exercise which is really interesting to do. As Tino, we did an open design of a gigawatt electrolyzer plant for both PEM and alkaline. You can see how such a plant looked like. But it will be interesting to see from what after like the end of life of certain electrolyzer plants, if you want to go to another technology. That's interesting. That's we didn't do such an effort. If you look at the complete balance of plant, but if you look at the stack, the step to between first and second is doable. If you go to third generation, it's your system will be more difficult. Yeah.
Okay. Yeah, that's a good point. So what would be some kind of steps maybe that electrolyzer OEMs, is there anything that comes to your mind as something that OEMs could do in order to make sure there's that continuous R&D and that continuous?
I mean, what you see now, I mean, a couple of electrolyzer manufacturers do everything in-house. They do the whole stack in-house. They make the CCMs themselves. They do a lot of things themselves. And I think from the state where the market is now, it seems logical because, I mean, you if you buy it externally, then you rely on 2 or 3 suppliers. But now you see that the number of suppliers are growing and the market is emerging. Then you can see from they maybe should focus on maybe or the certain parts of the stack design or the manufacturing and other components you buy in, or you go strategic alliances, because the biggest challenge is now is go to volume one and supply electrolyzers which are in the end are working, are safe and are producing. So it's now more on delivering. And then it's really, we see a big challenge is really manufacturing at large scale, at uniform quality on component and stack level. And I think that's the biggest challenge, and there you need partnerships. So go with partnerships, not doing everything yourself. I think that's crucial to go to high quality, high volume, and reliable electrolyzers. So I think partnerships is really crucial in that respect. Yeah.
Right. Thank you, Leonard. I see Irtem, your hand is up.
Yeah, thank you very much. Thanks for all the presenters for this nice webinar. My question is about the a general approach to the electrolyzers as a whole. What I see is, like you also mentioned, electricity is a main driver for the cost, and most of the time for the purpose of lowering the cost. Most of the electricity locations, which is like electricity generation locations, like let's say offshore or solar farms, we try to centralize the hydrogen production near those resources, and then distribution or storage becomes a cost, right? Like you try to create this network. Is there any kind of a study that you performed or you have read, you have seen, comparing this decentralized systems instead of trying to store and carry everything, like trying to make smaller plants, which is like closer to the location? Like, is it the electricity then is a problem is it the problem, like the bringing the electricity there, or is it like too costly to make smaller electrolyzer plants? I don't know if my question was clear, but I'm curious if there's any scaling factor or balance of plant comparison there.
Yeah, no, I think that's a really good question, Irtem. And actually, I know Piotr's just come off mute as well, because I was going to direct this towards you, Piotr. And in the paper, I'm not sure if you've looked at the paper yet, but we actually look at the on-site and off-site supply models, and there's a whole section on it. So Piotr, would you like to elaborate on the answer, please?
Yeah,
Yes.
curious about your inputs.
Thank you very much. One question, Erik, would you like to address this question? And then I can add something in case we need extra information.
Yeah, I can. Thanks for asking the question, and thanking for redirecting Piotr. So yeah, I would say add to whatever I have to say, or in case I don't address the question directly as such. I think that when you look far into the future, maybe not 5-6 years, but a little bit further, a decade, perhaps 2 decades, that you will see that the hydrogen will be produced in large quantities in those countries where you can expect electricity is really very cheap, such that you get, similar to oil and gas, perhaps major resource holder countries, central exporting countries in the Middle East, in sunny Chile, Mexico, perhaps even Saudi, the UAE, you name it, Sahara-based countries. And if that is really going to materialize and you would see a commoditized worldwide hydrogen market unfolding, you can expect really large electrolyzer facilities close to the site where also electricity will be produced. Similar actually to what's happening in oil and gas as well, because the major oil fields in the Middle East, for example, have the refineries on site. And that way, economically, these refineries capture a bit of additional margin as well. So on the large scale, in a commoditized market, you would have large electrolyzer facilities close to power generation sites. However, not all spots in the market, not all demand spots in the market, perhaps can easily connect to such a market. Because they're remote from seaborne routes or whatever, and there you would see perhaps a localized production, smaller units. So I think if you look into the future, you will have a mix of everything. You will have large-scale electrolyzers close to large-scale green power generation facilities, but you would also have smaller ones wherever you are in the world. So I think it's a very situational answer. Perhaps that's where I want to leave it, Piotr.
Yeah, maybe I can add the following notion. Indeed, there will be also, from my perspective, I think there will be a place for both models to develop. This utility scale, large scale application next to the local application, and of course there will be distinct business models governing those two major spots in the market that are being serviced by also probably various electrolyzer technologies. And also this will necessitate probably different financing models and different depth pricing. This large scale and those local generated, let's say, hydrogen utilities, mini or micro utilities. So indeed, there will be a blend. I'm not sure if this is full answer to your question.
Yeah. Thank you very much.
Yeah. Excuse me. I think we have some reports from the top of my mind. I think we have within TNO some sources that shed more light on the centralized versus local production of hydrogen. So if you exchange the data, contact data with me, I can make sure that you will get access.
Indeed. Thank you very much.
Yeah.
Fantastic. Thank you. Another one in the chat. Have you also done some quantitative analysis on the green hydrogen demand and supply per application for 2030 and 50 by Rajesh? Thank you, Rajesh. I think I might be able to answer this question myself, and any of the authors, please jump in. So we haven't done any independent analysis for this thought leadership piece. We have relied on data. We've done some research and relied on data provided by global institutions to understand what their projected forecast demands is for hydrogen, and we've tried to bring in data from different sources, having seen the assumptions that were made to get that data. So no, we haven't done any independent quantitative analysis, but if there is something that you are working on, or if there is something you'd like to see, we'll be more than happy. I think Piotr and myself have discussed trying to engage with the audience what the most important parts of this analysis are. We'd be more than happy to have a conversation with you regarding it, but as of right now, we don't. I hope that answers your question.
Perhaps, Erica, I can add.
Yes.
It is really very difficult to actually make any prediction at all when it comes to how the world might unfold in 20 or 30 years from now. If you look at the IEA scenarios from all the way from net zero emission scenario to the announced pledges scenario, you will see that even the IEA, with all the manpower, brain power, and computational model power, the range in terms of hydrogen demand, supply, and a sectorial breakdown is really very large. So how the future might unfold is really very uncertain. And as a matter of fact, the only thing we have that is, let's say, relatively reliable, and I really mean with relative reliable, are basically the policy plans for the next 10 years. So we need to rely in the world on the plans that are in place and the budgets that have been allocated. But how the world will unfold thereafter is really very uncertain. And even on the announced plans and policy, it's actually, I think, still uncertain as to whether they will really be fully implemented. So I just want to make that statement clear, that the future is uncertain, and that for that purpose, I think it's best to also let organizations like the IEA do the number crunching, and please be aware of that uncertainty in the future. Thank you.
Completely agree.
Maybe Erika, if I may add, I agree with the uncertainty of Erik. Although there are some big, bold things, for example, if you look to Europe, the biggest hydrogen demand sector will be obviously the steel industry, where you see a lot of initiative towards hydrogen. You see the aviation, obviously you see there the mandate, which again policy, go to e-fuels. So aviation, steel industry, these are the new sectors which will have huge hydrogen demand. Obviously, you've got the sectors, the industry which are already using the hydrogen. But the new hydrogen will become from steel and aviation, shipping. These are the big, huge amount of offtakes in the future. Yeah.
Okay. Thanks, Leonard. That's actually a good segue into a question that I personally have, and we've mentioned it in the report. And this is for you, Ian, and anyone else who'd like to add. But we've been talking about, okay, maybe the steel industry coming up, maybe the aviation industry coming up. And the fact that policy is really determining right now what the future demand is going to be. So let's say there is this push towards electrification, and our passenger cars are more electrified. There's a reduction in demand for fuel, liquid fuel as we know it. In a scenario like that, how will the expected reduction in the oil and gas demand forecasted impact the demand of hydrogen in refineries? Then is there a correlation there? And if so, then what is it, Ian?
That's a good question. As you know, we spend a lot of time wondering what the refinery of the future might look like in 2040 and 2050. And we know refiners themselves are on a decarbonisation journey, I guess initially focusing on scope 1 and scope 2 emissions. And in terms of scope 1, I guess just decarbonising your own grey hydrogen use. So in a sense, that could be a growth area for refineries in terms of low carbon hydrogen usage. And then obviously many refineries are focusing on scope 3 emissions, and I guess that's where we get into the world of biofuels, which is again, production of renewable diesel and the like is increasing low carbon hydrogen demand. So obviously with EV, we would expect to see a decrease in demand for like passenger vehicle fuels, liquid fuels. Within a refinery, it might mean that naphtha gets shifted from gasoline production into petrochemicals. It doesn't necessarily mean that a refinery will reduce throughput. And then I think it really comes down to what happens to the refineries in the future. I think some of them will just sort of double down on what they're doing at the moment and ride that to the end almost, whereas we see other refineries really gearing up to produce the new fuels, the particularly like e-fuels and maybe even ammonia. So in that scenario, the actual growth, in terms of hydrogen demand, particularly if we went down the e-fuel route, and aviation fuel, then still hydrogen needed as part of the processing in the short term, more the HEFA route and the biofuels, bioenergy feedstocks route, and ultimately into the e-fuels route. So because refineries can go in different directions, I think some of them will need a lot more hydrogen in the future, and maybe some of them will need less.
That's a good point, I think. It's a good point. Anything to add by our panelists? Or we continue. We do have a full array
maybe
of
one
questions.
general remark. What I see in many boardrooms, then at the moment hydrogen is coming in, everyone getting enthusiastic, but hydrogen is not a goal in itself. Hydrogen is a mean to its ends, basically. So it's or decarbonization or energy security or air quality. But from a societal perspective, hydrogen is not a goal in its end. So we need to always be critical. I think by pushing hydrogen, I mean from a hydrogen supplier developer, I can understand. But from TNO perspective, we see hydrogen as a means and not a goal in itself. So always look where is the best technology option. Let all technologies get their role, basically. Yeah.
Yeah, perhaps what I can add, Erica, is that I believe today's hydrogen consumption is around 90 million tons a year. Let's assume global refining takes a third of that. So that will be, let's say, 30 million tons of hydrogen a year. In order to produce 30 million tons of hydrogen a year, you need something like 150 gigawatt if I do the calcs right on the back of an envelope. So 150 gigawatts of electrolyzer capacity, which is enormous, which is really huge. So you could argue if indeed the refining industry wishes to replace their hydrogen by green hydrogen, then it will have an enormous impact on electrolyzer capacity demand. Almost impossible to satisfy, I think. Over to you.
No, that's right, I think, and the whole idea of making these projects a reality and making this green hydrogen projects a reality is a good segue, I think, into our next question, which I think Piotr and Christiane, I'm going to direct towards yourselves. Piotr, you mentioned earlier bankable, the whole idea of bankability, about how the financial world is going to work in order to help us put in these gigawatt scale electrolyzer projects to satisfy our green hydrogen demands that we anticipate in the future. Can you please describe, and Christiane from a legislation perspective and the requirements perspective, and Piotr from a purely financial perspective, what makes these projects bankable?
Thank you for passing this question to me, Erica. Generically speaking, I think that in our study, we touched upon the bankability as a term, which is a collective or combination of different aspects put into one word. And in principle, all projects, large investment projects, that and certainly clean hydrogen, it falls into category of large products. It's very wise to look for those at those projects through the perspective of bankability, and just to remind or refresh our listeners, bankability is a marketing contract, right? So at this moment in time, we really don't see a large scale power purchase agreements related to the clean hydrogen projects, and without those large scale PPAs, it will be very difficult for the market to take off. Everything what we have at this moment is also grants and subsidy connected. So with this connection, you can say we are still in the kind of incubation phase with the market. It will be difficult to start. And this is because of the fact that clean hydrogen at this moment is economically speaking not viable yet. If we go to the level of, let's say, 1.8, 1.7 euro per kilogram, we might certainly get to the level where we have no problems with finding financing, and then we have the brakes off and we can really start. And this facilitates the market in a sufficient way to really explode. And also the funding models at this moment in time as such are based on this debt, but supported by government funds, by government subsidies. And as such, those projects in the near, even in the near future, and I will then pass my part on to you. We have this opportunity of introducing the taxing mechanisms and the carbon credits mechanism, and those mechanisms are maybe have a potential for the market to really take off. And maybe we can just concentrate a bit on the timing and the real feasibility of those releasing of those mechanisms like carbon credits. When will they be introduced on a full scale, and when is the moment that the financeability of the project will then improve drastically? And Christine, maybe you can have some comments on this one.
Yeah, well covered, and yeah, just complementing. So the bankability requires strongly legislation in place, as the feasibility of the most of these green projects rely strongly on subsidies and financing. So exactly as you saying, like the bankability is referring to the legislation certainty to provide incentives and make feasible all these green hydrogen projects. I think, yeah, so there is a lot of happening right now. So we have like the funding, we have like the innovation funding across Europe. We have like a lot of this legislation coming up in order to provide this certainty and make sure all these projects will be feasible and ready to go to the market.
But how do you assess the feasibility of introducing a really disruptive model allowing large-scale power purchase agreements or hydrogen delivery agreements in such a way that we really kickstart the market, which is not really happening right now, right?
What's
your feeling?
I think so. We are like in an early development of these policies. So as I said, these projects will be strongly reliant on the policy, on subsidies, on financing, and we have been seeing like a lot of this funding and try to scale up these green hydrogen projects. I guess it's just like a start point where we're gonna speed up in the next coming years all these aspects. So I think we need to have like different mechanisms to support these green hydrogen developments.
Yeah,
I agree, and I think we're seeing a bunch of different models right now. We know of a couple projects that are being financed privately. We know many projects that are being financed in partnership with governments, in partnership with funding bodies. And one of the biggest requirements when it comes to these financing of projects has to do with understanding the entire supply chain, as we spoke about, ensuring you've got that PPA, ensuring you've got that offtake agreement, ensuring you've got a good electrolyzer manufacturer lined up, a location, reliability of renewable energy supply, and really covering your bases and having certainty in a very uncertain environment right now of what your project is going to look like. And that's been a very big concern for project developers and for financing bodies as well. Go on, Piotr, I see your hand is up.
Yeah, maybe one remark on this one. It's also very much clear that this phase, the market needs also a very strong EPC bodies that may deliver turnkey contracts, projects, de-risks, and also fully functional projects. And the lack of those parties, like strong financially, technically strong APCs, also hamper development of not only the supply chain but large-scale projects as well. And in principle, parties like Worley, I'm not sure how if Worley fits into this EPC profile, but probably it might be. those companies are difficult to find, and if we have few of them developed in the market, this will certainly also ease the creation of the mature supply chain and take off of the large-scale projects.
Good point, Peter, and a good closing remark probably as we are now on top of the hour. We haven't gone through all the questions, and we do apologize for not making through all of them, but maybe we can share our email addresses. We'd be very happy to continue this conversation for everyone that's joined. Thank you so much to our panelists, Eric, Leonard, Ian, Christiane, Piotr, Lisette, for putting together a wonderful webinar for us on such short notice. The paper is online for everyone to download. We are very happy to be questioned. We're really happy to create a conversation for it, and we would love to keep in touch with you. So thank you so much for joining. We look forward to keeping the conversation going, and have a lovely rest of the week, everyone. Thank you.
Thank you very much.
Thank you.
Thank you, everyone.
Thank you.
Thanks.